And again, this is like the perfect example of why calculus is considered to be difficult. And it really is not anything to do with the calculus. The calculus says, try direct substitution, but you get 0 over 0. But then the calculus says, okay, we call it indeterminate form, rewrite it somehow so that you don't get indeterminate form. Now, basically, the calculus is done until the very last step. What makes this question difficult is to say, how can I rearrange this? So how do we rewrite this so we don't have these smaller fractions within this bigger fraction? How did we do that in algebra?
You multiply it by x plus 4 over x plus 4.
Multiply it by x plus 4, and then what was the other part?
Conjugate. X plus 4 over x plus 4, so that it's 1 to 1.
Okay, yes, you could do that. So really, if I multiplied, and I'm going to write it a little bit differently. We all agree that this is just like multiplying by 1, right? Well, let me go ahead and distribute it. So I'm going to distribute this to the denominator. And I'm going to distribute this to both terms of the numerator. So this one gets an x plus 4, and this one gets an x plus 4. How is that helpful? Right. So now timesing by x plus 4 and dividing by x plus 4, those cancel out. So I still have a smaller fraction within a bigger fraction, but I don't have two smaller fractions at least, right? So multiplying everything by x plus 4 pushed me in the right direction. What else should I multiply everything by?
1 over
Well, you're trying to get rid of this. Yeah, you're trying to get rid of this last denominator here. Right. So multiplying this one by 8 makes those cancel out. But you can't just do that because you're essentially just erasing this and pretending like it's not there. You'd have to multiply everything by 8. So it's okay to multiply by something, just make sure it gets distributed to everything. Now, the hardest part about this is that it gets kind of messy. But since these canceled out, the only thing left here was 8 times 1 minus, the 8's canceled out, so that what was left was 1 times x plus 4. And this is minus the whole thing, so make sure you say minus the whole thing. Down here, I have an 8, I have an x minus 4, and I have an x plus 4. This wasn't a smaller denominator, so I didn't have anything to cancel out with. Okay, so I guess we could try direct substitution again. You could plug in 4, but since nothing's canceled out, it's probably still an indeterminate form, right? It probably still needs some work. So I got it out of complex fractions. There's not smaller fractions within a bigger fraction, but we still need to do something else. So I'd say probably combine like terms here. Distribute this negative and combine like terms. So this is like negative x and plus 4. Everybody see that?
Why doesn't the x plus 4 on the top and x plus 4 on the bottom?
Well, because right now they're terms. This is being added or subtracted to something, so you can't just cancel those out yet. You can't cancel out terms, but you can cancel out factors, which is what I'm about to do. So if I distribute this and combine like terms here, this amounts to negative x plus 4. And that's close to one of these, right? I'm trying to get something to cancel out. So it's not exactly what I need, but what if we pulled that negative out and wrote it like that? So I factored out a negative. Now those terms cancel. And now that something canceled, direct substitution is probably going to be fine. So now back to calculus. Remember, we started with calculus. We did a bunch of algebra steps that weren't fun, not necessarily easy, hard to keep up with, but it wasn't calculus. And then we get to this where we got to finish with calculus. If I try direct substitution again, I get -1 over 8 times 8 to -1/64.